All right, so in our 484, 485 folder, like I said, the trig stuff is kind of its own animal, and that's by itself. So I'm going to make a completely new note sheet. And when I'm done, I'm going to label this Intro to Polynomials. So I'll put that up here as well. And as always, if I go too quickly or you guys have questions, just blurt them out. I'm more than happy to slow down or answer anything that you guys might want to know. Well, the first thing you might want to know is, well, what the heck is a polynomial? So, a polynomial comes from really two parts here. Poly, meaning many, and nomials is terms. So a polynomial has many terms. Many to you and me, we think of a lot, but it doesn't have to be a lot. It could be two terms, could be a polynomial. One term actually could be a polynomial, but you could have a polynomial with 100 terms or 1,000 terms. Okay, so many just is kind of this thing of saying it just has a certain number of terms. Now, another characteristic of polynomials that is really important is that all of the exponents of every term, so the exponent of each term is a positive integer. So the exponents, like x squared, the 2 is a positive integer, okay? Positive integers would be like 0, 1, 2, etc. Okay? Fractions like that. All right, so for example, I'm going to write a polynomial, and then we're going to start to classify them by name and by how many terms they have. So if I had something, and I'll do something that might be familiar to us, something like x squared plus 6x plus 5. That's a polynomial. It has 3 terms. The exponents, which are this one and x to the first, of course. And actually, you don't really think this, and no normal person would, but this actually is 5x to the 0 power. When you just write a constant, it actually is times x to the 0, because remember, anything to the 0 is equal to 1. So that's actually 5x to the 0. And so 2 is an integer, 1 is an integer, 0 is a positive integer. So that makes that a polynomial. And I'm going to erase that now because we would never think, write it that way. That x squared plus 6x plus 5 is a polynomial. More specifically, to name that, it is a second degree trinomial. Now the degree is the highest exponent. So since 2 is the highest exponent, that makes it a second degree. Trinomial, that's a specific name for the polynomial. Tri, meaning 3, it has 3 terms. Okay, 1, 2, 3. Because it has 3 terms, it's a trinomial. So that's a second degree trinomial. Okay, I'll start with another one. If we had, 4x plus 2, that is a first degree binomial. First degree because x to the first power is the highest exponent. So that is a first degree. And binomial, bi means two, nomial means terms. So it has two terms. So if something has two terms, it's a binomial. If it has three terms, it's a trinomial. Once we get above three, we typically just say a polynomial. So let me give you something that, a crazier thing. So something like 4x to the fifth minus 6x to the eighth plus 2x to the third minus 8x squared. So that's big and ugly, but that is a polynomial. Now be careful. The highest exponent is the degree. So that is an eighth degree because 8 is the highest exponent. So it is an eighth degree polynomial. So we would say that is an eighth degree. And we would just call that a polynomial because it has four terms. So we wouldn't give it a specific name like a binomial or a trinomial. And some other, common terms are the coefficient. So in this case, the coefficient is 4. Okay, for that first degree binomial, the coefficient is the number in front of the polynomial. This coefficient is 1. Now, when they talk about the coefficient, because polynomials are typically written in descending order, but I didn't write this one this way, the coefficient of that polynomial actually would be -6. It's the number in front of the largest variable there. All right, one other example that, just to point it out, I think once I say it will make sense. Any number. So if I said -3, that actually is considered a polynomial. It is a 0 degree because that's like -3x to the, x to the 0. But of course, we don't write the x to the 0. So that's a 0 degree monomial. Mono meaning one. A monomial only has one term. All right, let me give you two more examples. Let's say we had 4x to the -6th minus 2x to the third. So 4x to the -6 minus 2x to the third. That's not a polynomial. So we can't name it, okay? We can't name it like a polynomial by degree or by term. It's not a polynomial because remember, all the exponents, they have to be positive integers. So -6 is not a positive integer. It's not positive. So that's not a polynomial. If you had another example like, let's say, the square root of x minus 4, that also is not a polynomial. It's not a polynomial because remember our roots. The square root means x to the 1/2. 1/2 is not a positive integer. It's not an integer. So that means that that is not a polynomial. So we'll spend some time today just classifying these things and talking about a little vocabulary. What degree is it? how many terms does it have? Is it a binomial, a trinomial, a polynomial? So that will be something that we're going to practice in the Kahoot in just a little bit. So before I move on to something else, are there any questions on that? Okay, so now I'm going to do a couple of different operations of polynomials. So if we wanted to multiply polynomials. Well, you guys have been doing this for a while. Sometimes it's better known as FOIL. You know, you did foiling, and when we did our factoring unit, and you guys have done that in Algebra 1. But if we had something like 2x minus 1, that's a polynomial. That is a first degree binomial. So if we multiplied that binomial by x minus 4 by that binomial, so just to throw some terms around, we are multiplying two binomials, we would FOIL that out. So we get 2x squared, and I'm going to do that kind of quick because we've done a bunch of these, minus 8x minus x and plus 4, or 2x squared minus 9x plus 4. So to throw some vocabulary out there, we multiplied two first degree binomials, and our result was a second degree trinomial. So let me do another one. Let's say we had a binomial of x squared minus 2x. And we want to multiply that by a trinomial. How about x to the third minus 4x plus 1? So we're going to be using the same method, kind of our foiling method. I have to just multiply x squared by this, this, and this. And then I have to multiply negative 2x by this, this, and this. So I'm going to have a bunch of terms there. It's going to get a little messy, but as long as I'm methodical and I keep it organized, I should be in good shape. We have to remember our rules of exponents when I start off. So x squared times x to the third, remember, is x to the fifth. We add exponents, not multiply. So x squared times negative 4x is minus 4x to the third. X squared times 1 would be plus x squared. So I multiplied x squared by everything. Now I'm going to multiply negative 2x times everything. So that's negative 2x to the fourth. And that's going to be plus 8x squared. And then minus 2x. Now we really should combine all of our like terms and write it in descending order, meaning our highest power first, so that I have 1x to the fifth. And let's see, I have negative 2x to the fourth, so minus 2x to the fourth, minus 4x to the third. So again, I'm writing it in descending order, like my exponents go 5, 4, 3. And for my squared terms, I have 8x squared plus x squared, that's plus 9x squared. Don't forget to combine your like terms. And then minus 2x. So again, in our terms, I had here a second degree binomial times this, which is a third degree trinomial. And my result was a fifth degree polynomial. So I had 5 terms in my result here. All right, so I did some multiplying. Next, I'm going to do some solving. So before I move on to that, do you have any questions on the multiplying polynomials? You guys are making this Friday easy on me here. All right, well, let's then, I'm going to solve some problems a couple different ways. So first, we are going to solve by factoring. So we might have, let's say, 3x squared plus 10x minus 10. So like that second degree trinomial. And let's say that's equal to -2, which is a 0 degree monomial. And we want to solve this for x. Now, there are a number of different ways we can solve this. So I think in order, first, it is a quadratic. I'm going to get everything on one side. So I have 3x squared plus 10x minus 8 is equal to 0. So I moved that -2 over. I added 2 to both sides. And at this point, I can tell, all right, I have a quadratic. I want to know when the quadratic equals 0. I might have 2 answers. I think about what this shape would look like. I know it's a parabola. When does a parabola hit 0? It might hit it twice. It might not hit it at all if the x-axis is down there, but I could have 0, I could have 1 answer, I could have 2 answers. I can't have more than that though. I could do the quadratic formula, which to me is not the most efficient way, because if you can factor it, you want to factor it. So, but the quadratic formula always works. So my rule is, for myself, I try and factor it first, and if I can't factor it in 20 seconds, then I stop and do the quadratic formula. But I think it's worth the 20 seconds to try and factor this. So I'm going to do that. We have a leading coefficient other than 1, so I know that's going to be 3x and x. And now I need factors of 8 to go in my last 2 spots. So I can see if I did 4 and 2, that's going to be 12x and 2x. So as long as I had positive 12x and negative 2x, I would get positive 10x in the middle, and I would get -8 on the end, so it factors. So to me, if I'm able to factor that fairly quickly, I think that's the way to do it. We will get the same answers using the quadratic formula, it just would take a little bit more time. Because now I can use the 0 product property where I set this equal to 0 and solve it, and set this equal to 0 and solve it. So I do 3x minus 2 equals 0, and x plus 4 equals 0. I'm going to get my 2 answers. So I'll add the 2 over. So 3x is equal to 2, and x is equal to 2/3. And over here, x is equal to -4. Those are my 2 answers. So I solved it by factoring. Now, one connection I would like you guys to just start maybe getting in your head is, okay, that tells us something graphically. If I think about this graph, I know x squared, it's a parabola. There's a positive leading coefficient, so it's going to open upward. It's going to hit the x-axis at 2/3 and at -4. So I have a little bit of a visual. I know, I'm going to erase this in a minute, but just to show you, it's going to hit at 2/3 and -4 here, and it's going to open upward. It's going to look something like that. Okay, so by solving that, I have found some things that graphically, hopefully, are making sense. Okay? We'll do one more. And I'm going to solve the next one by square roots. It's a real similar problem. which we could solve perhaps the same way. So let's say I had 2x minus 1 squared. So the quantity 2x minus 1 squared is equal to 9. So this is another quadratic. So I have 2x minus 1 squared is equal to 9. I could FOIL all this stuff out, move the 9 over, try and factor it like we did in the last problem, or use the quadratic formula. However, this is a little different because it's different than the last one. See, here I have my squared term by itself. Up here, I didn't have that chance, okay? So what I could do is I could right now just take the square root of both sides. When I take the square root of the left side, I just get 2x minus 1. And the square root of 9 is 3. But don't miss this big thing right here. It is plus or minus 3. And one thing to help me remember that is I should get 2 answers, or I might get 2 answers at least. So I take the square root of the left side, and I just get the 2x minus 1. But when I take the square root of the right side, it's plus or minus. So now I have 2 equations. Just like before I had 2 equations, I have the same thing here. We have to solve 2x minus 1 is equal to negative 3, and 2x minus 1 is equal to positive 3, because it equals plus or minus 3. And so I'll solve both of those. So 2x is equal to negative 2, 4x is equal to negative 1. On the right side, I get 2x is equal to 4, or x is equal to 2. All right, so again, I know that it's quadratic. This is saying, when does that quadratic hit 9? Well, if 9 is up here, I mean, the quadratic, it's going to hit it twice, or it can hit it twice. It actually hits it at negative 1 and positive 2. So it tells me something graphically about that problem. All right, I got one more for you guys. So hang in there. I'm going to solve by square root again, but this one's going to be a little harder because sometimes they get a little bit uglier. So let's say we had 4 times the quantity 3x plus 1 squared minus 3 is equal to 17. So again, I could FOIL all this out and distribute the 4 and move the 17 over and use the quadratic formula or try and factor. But because I have this term squared, that allows me to also use another method where I can just get this thing by itself and take the square root of both sides. So I'm going to move the 3 over by adding 3 to both sides. So we have 4 times quantity 3x plus 1 squared is equal to 20. And then we're dividing by 4, so we have 3x plus 1 squared is equal to 5. 20 divided by 4 is 5. And now we're kind of like, this step from the previous one, where we're going to take the square roots of both sides. So when I take the square root of the left side, we just get 3x plus 1. But don't forget, when you take the square root of the right side, we have plus or minus the square root of 5. And that's why this one is a little uglier, because it's not a nice number, the square root of 5. Okay, but even though it's not a nice number, I still can write my 2 equations. So I have 3x plus 1 is equal to negative root 5, and 3x plus 1 is equal to positive root 5, and I want to solve it for x. I'm just going to get a weird looking answer. So if I subtract 1 from both sides, I have 3x is equal to negative 1 minus root 5. Or x is equal to negative 1 minus root 5 over 3. And yes, that is our answer, one of our answers. And same thing over here. I'll move the 1 over. So I'm going to write negative 1 plus root 5. And you can write those in any order, by the way. The radical is typically written second, but it doesn't have to be. And so our other answer would be negative 1 plus root 5 over 3. There are our two solutions. Okay, and that tells me something again graphically. It means that the graph of this thing does cross 17 twice. It just doesn't cross at an integer value. It just crosses at, a couple non-integer values. All right, so just to recap quickly, we started off talking about polynomials. And the key with polynomials is that the exponent of each term has to be a positive integer. So if we wanted to classify this polynomial, that is a second degree and trinomial because we have 3 terms. Okay, so we can classify it by degree and by how many terms. These, by the way, were not polynomials because negative 6 is not a positive integer, and 1/2 is not a positive integer, so those are not polynomials. We then multiplied some polynomials. Okay, so we had 2 examples. One was harder than the other, just had more terms to it. We solved the problem by factoring, and then we solved by square roots. All right, before I leave this note sheet, are there any questions or anything you'd like me to go over again?